Interactive Key Game. Our senior design project was making an interactive key game. The group members of this project were Ann Meyer, Jake Sebald, Joe Lianza, and me, Zach Allison.
About us in the division of work. Ann Meyer and Jake Sebald worked together to program the system. In addition, Ann acted as the project leader. Joe Lianza and Zach Allison built the system hardware and console to house the hardware. Joe facilitated the communication between hardware and software, while Zach created the electrical schematics and designed the console to be bird resistant. About our project. The keas are a parrot species native to New Zealand. They are known to be incredibly intelligent and curious birds. Researchers have tested the intelligence of crows and parrots in the past with puzzles that reward treats. Our project seeks to further that goal and test key intelligence with a virtual system that is also fun for zoo patrons. Intellectual merits. Our greatest intellectual merits will be any research discoveries made through the interactions with the Kia. This could include anything from the social nature of the birds, their ability to see screens in color, and to their ability to think critically in real-time applications. Project impacts. This project intends to allow the Cincinnati Zoo visitors to interact with the Kia birds. The system will need to be safe to interact with for both the guests of all ages and for the Kia. The system will be composed of 2 separate monitors and controllers. The intent of this project is to allow for data collection and research about the Kia birds while providing an interactive exhibit at the zoo.
Technologies. We use multiple different technologies on this project. We used a Raspberry Pi with Raspbian, which uses Python, so that's why we then created our game using our Pong game in Python. We found this third-party library thanks to Vino the Pandinian. We modified the game that he gave so we could better fit it for what we needed. We used CAD modeling software to kind of build out the structure, and we went through a couple different design ideas with that. We used Windshuttle to move things so we could program, and then we could have everything done remotely for actually pushing everything to the Raspberry Pi. And like we also have GitHub, like we used for other parts of the project and for finding our Python, and we used buttons along with other electrical wiring for the actual to make it arcade and give the birds the ability to push the button and humans to push the button as well. How to play. The idea of where our box will be sitting will be outside of the bird enclosure at the Cincinnati Zoo. A zoo guest would come up to the box and look at the player controller, which has 3 buttons with the center one being a white start button. They'd press the white start button, and an indicator light on the Kia's controller, which would be inside the cage, would start flashing. Once that starts flashing, the Kia bird should then come to the controller, push the button to activate the game, and once he pushes the button and is there, the game will start. From there, normal Pong will commence. The ball will move randomly one way to start, and the player and the Kia bird have the corresponding right and left buttons to move the paddle in the game right or left. The game ends when either player scores a point, and the winner of the game is displayed on the screen. This process can be repeated as many times as the visitor would want by pushing the start button again to allowing a new game to bring up and start. Software. For the software, we utilize an open source Pong game, which we mentioned with the link on the technology slide. The code did not work originally, and we needed to be completed, and then we needed to go the extent again of modifying it now to work on a Raspberry Pi and work with the GPIO interface that the Raspberry Pi handles. This included the signal light and including programming the buttons to work. The buttons had to be forced into the library using kind of like a force into the event to signal the button movements. Pong was chosen for its simplicity. We used Raspbian OS for the ease and a highly documented OS that it is. And in the future, Zoo would be able to likely modify what game is running on the Raspberry Pi as the Kia learned to interact with the system. The OS would simplify the process for the Zoo to implement new Pong games, and future new Pong games could help research and learn about the mental capabilities of the birds. So the big help with this would not be just giving one game built with this. You could have multiple games using these 2 buttons.
Design specifications. For our design, we needed to construct a product that was weather resistant. The reason it had to be weather resistant was because this would be outside of the birdcage exposed to weather. The design also had to prevent the birds from being able to get into the electronics for the birds' safety. Our design also had to be easy for the zoo staff to service the product in case a part went bad or wanted to upload a new game on the system. Hardware. The hardware inside the box was powered by 3 different voltages. The first was 120-volt AC, which is available from a wall outlet. The 120-volt AC powered the monitors, Raspberry Pi, HDMI splitter, and the power supply. The power supply provides a 12-volt DC power that powers up the button LEDs and pilot light located on the bird's controller. The Raspberry Pi has a 3.3-volt DC output, which would allow feedback from the button to be read by the Pi's GPIO. The GPIO also outputs a 3.3-volt DC, which allows the Pi to control the relay, which in turn controls the pilot light. Another part of the hardware was to display the Raspberry Pi's HDMI output to both the monitors. On the Pi, there is only one HDMI output, so to solve this problem, we used an HDMI splitter. The splitter took one HDMI output and converted it into 2 outputs. With the 2 outputs, we could then display the game on both monitors.
Milestones. So these milestones date back to last semester when we began our project. In November, we began working on our hardware design and our software development. Around mid-November, we completed purchasing all of our hardware and we were able to move on to assembling our first prototype. In the fall semester, overall, we completed building a hardware prototype and completed working on the software development beginning phase. In the spring semester, we moved on to testing the hardware and software components together and making sure that there were no outlying issues in either one or while they were put together. In February, we moved on to building a case and a stand, which required weatherproofing and birdproofing our design. We began to work on a demo in early March and our presentation, and we had originally planned to install the game at the zoo and train the Kia and record a demo of the birds interacting with our project. However, due to the current stay-at-home orders, we were unable to complete this milestone. However, this is something that we would potentially like to do in the future if the current status of things changes. Project accomplishments. We met with the zoo staff and the Kia birds to get a better understanding of what the Kia are capable of doing. We utilized open source Pong and implemented modifications for the code to work with our system. We completed a phase of software testing. We utilized CAD modeling to develop a hardware design. We constructed a weather and bird-resistant structure to house the system. And finally, we completed testing with the hardware and software implemented together. Some future accomplishments that we would still like to see happen. As I previously mentioned, the first one is handing off the system to the zoo to begin training with the Kia. The next one is tied in with the third accomplishment, which is implementing a reward system using RFID chip technology. The birds were previously chipped or had a different type of technology. However, they took the tags off, and in order to implement a reward system, we need to know which birds are interacting with our system because our rewards are going to be based on treats. And if we give too many treats to one bird, we could cause harm to their diet. So until we are able to RFID chip the birds, we cannot implement a reward system. Throughout our project, we encountered a few different challenges, and I'm going to talk about 3 of our biggest challenges along the way. The first challenge was our budget. Originally, we wanted to 3D print a design to weatherproof and birdproof our system, but we discovered how high the cost was going to be. We reevaluated and decided to build our own case using wood and plexiglass. We ended up saving over 50% of the cost. However, we put in many hours of labor in building this design. In the future, our system could be rebuilt using 3D printing to produce a cleaner looking and a more weatherproof design. The next challenge was bird and weatherproof resistant console. The birds and weather provided a challenge because they could damage the system and the wires, or the birds could harm themselves. Originally, we were going to create 2 units, one for the guests and one for the birds. Both the units would need to be bird and waterproof. We decided to build one system that is outside of the bird's enclosure, so the birds have minimal access to the system and only have access to the buttons. This helped to bird-proof our design because the birds had less of a chance of harming themselves, and the design was weatherproofed using the plexiglass to protect the screens as best that we can. The final challenge we encountered was rewarding and collecting data. As I previously talked about, due to budget and general time constraints, we were unable to overcome this challenge. Implementing a reward system without having the birds RFID chipped could be harmful to the diet of the birds, so there's no way to track which Kia was being rewarded. With our system, though, the zoo is hoping that they're able to have the birds RFID chipped in the future so that this feature can be implemented and will encourage the birds to participate with our project.